Whether you realize it or not, we are surrounded by decimal numbers. When someone says their temperature is 98.6 degrees Fahrenheit, they're using a decimal number. When the weatherman says that we received 1.25 inches of rain yesterday, he's using a decimal number. When we walk into a store or we read the menu at a restaurant and we see a price like $10.99, we're seeing a decimal number. And when the sports announcer says that a runner won his race with a time of 10.27 seconds, she's using a decimal number. When that baseball statistician talks about a lifetime batting average of .267, a decimal number is coming into play. No pun intended. There are lots of technical ways that we could define a decimal number, but basically, a decimal number is a number written in our usual number system of base 10. Often, they will involve a decimal point, that little dot that you saw in all the numbers I mentioned a moment ago. Decimal numbers are extremely important in our everyday lives, and therefore it's critical that we know how to work with them. In this lesson, I want to talk about a few facts about decimal numbers, and then we're going to look specifically at how to add and subtract decimal numbers. Now, a few lessons ago, we talked about whole numbers and what their digits actually mean. So, for example, when we write the number 728, we mean 7 hundreds and 2 tens and 8 ones. But what if we write a number like 728.395? What does that decimal number mean? Well, the 7, the 2, and the 8 still mean what they meant before, 7 hundreds and 2 tens and 8 ones. But what about that 395, which was written to the right of the decimal number? Well, they also mean specific things, and the decimal point actually helps us to know what they mean. They're in their own digits, basically, as we look at them. And basically, the .395 means 3 tenths and 9 100ths and 5 1,000ths. Now, it may be hard for you to hear that I'm trying not to say tens, hundreds, and thousands, so let me emphasize this again. The 3 is in the 1/10ths position, so it stands for 3 1/10ths or 3 tenths. This is not 3 tens, which would be 30, but it's 3 tenths. Not only is it not 30, it's not even 1. It's less than 1. It's just 0.3. Imagine cutting a pie, or one of those pizzas again, into 10 equally sized slices and then taking 3 of them. Those 3 pieces represent 3 tenths of the pie, so they're not even one whole pie in the process. And the 9 in this number represents an even smaller quantity since it's only 9 100ths. Imagine starting with a new pie and cutting it into 100 tiny pieces of equal size. Then you just take 9 of those away. And that is what this 9 in the number represents. It's not very much. Having 0.09 of a pie just isn't that much of the pie. And lastly, the 5 is in the 1,000ths position, and this is a tiny, tiny part of a whole pie. In fact, it probably wouldn't even be more than just a little crumb. With this gentle introduction to decimal numbers and what some of those digits mean to the right of the decimal point, let's begin talking about how we go about adding 2 decimal numbers. In a few moments, we'll also talk about subtracting these kinds of numbers, but let's start with adding first. Let's make sure we understand how to add decimal numbers. There's one very, very important thing that you always need to remember when you add 2 decimal numbers. You always have to line up the corresponding digits. We said this very same thing when we were adding whole numbers several lessons ago, and it's just as important now when we're dealing with decimal numbers. Thankfully, with 2 decimal numbers to add, the lining up process is usually pretty easy. If you just line up the decimal points in each of the numbers and then keep everything else straight, sort of keep everything else in their own column, you'll be good to go. Now, let me make one quick suggestion that might help some of you. For some students who are new at adding decimal numbers, it might help to find some grid paper with pretty good size grid boxes on it and write the digits of each number, one per box, as you do these problems. That kind of structure on the page can be a huge help in keeping all the digits lined up really nicely. Now, let's start with a quick example, just to make sure we have the basic idea in place for adding two decimal numbers. Here's the problem I'd like us to look at. Calculate 27.4 plus 31.5. All right, we need to add these two decimal numbers, and the first thing we have to do is write them vertically, one above the other, just like we did with whole numbers, and now we're going to line up those decimal points. When we use the decimal points as our markers, so to speak, to get everything lined up correctly, then you're going to have 27.4 above and 31.5 below. We're adding them, and we've lined up those decimal points. Now, it's okay, by the way, that the 27.4 is above the 31.5, even though the 31.5 is actually the larger number. It's okay to do because when we add two numbers, the order in which we add them doesn't matter. Now, I have a habit of forgetting my decimal point in my final answer. So at this stage, we need to write the decimal point in the answer section, which is below the two numbers that we've already written. So I like to write my two numbers, draw a little horizontal line to show where the answer is going to go. It'll always go just below that line. And the first thing I'm going to do is write my decimal point right into the problem. Now, it's important that I put that decimal point just below the other two decimal points that were in the problem. Everything has got to be lined up really nicely and neatly. So make sure you put that decimal point in now. Now, as with whole numbers, I'm going to add the corresponding digits exactly in the same way that we did several lessons ago with those whole numbers, and I'm going to move right to left. So this feels very much like whole numbers, except those decimal points are now floating around in the problems. Really though, the rest of this problem is done just like with adding two whole numbers. 4 plus 5 is 9, so I put a 9 in my answer section just to the right of that decimal point. 7 plus 1 is 8, and so I put that 8 in below the 7 and the 1, just to the left of the decimal point. And 2 plus 3 is 5, so I put that 5 in my answer section as well. And I see here that my final answer is 58.9. Now, again, it's very important that we not forget that decimal point. That's why I made us write it in the first place. My answer here is not 589. Do you see that? The answer is just 58.9, which is a little less than 60. I definitely don't want my answer to be 589. That would be too large. Now, let's try another example which involves some carrying. Remember, we had carrying with whole numbers. You can have carrying with decimal numbers as well. So here's the example I'd like us to look at. Let's find 29.42 plus 84.67. And let me suggest at this point that you take some time and try to handle this one on your own. Then we'll come back together and see how you did. Well, we're going to begin as before by writing the problem in a vertical fashion, and we're going to line up those decimal points. So I'm going to have my 29.42 plus 84.67 lined up nice and vertically. Notice the decimal points are lining up. And of course, the 4 and the 6 are going to be lined up. The 2 and the 7 are lined up to the right of the decimal point. And then the 9 and the 4 and the 2 and the 8 are going to be lined up as well. So everything is nice. I'm then going to draw my horizontal line. And the first thing I like to do now after drawing that horizontal line is put that decimal point right below the other two decimal points in the answer section. I've got to put that in. I don't want to forget it. And I'm going to put it in right below the other two decimal points. That's perfect alignment as I get ready to do the problem. Now, once I've written in that decimal point, I just start adding the digits again. And I'm going to do it from right to left, just like we did with whole numbers. Now this time, I have to remember to handle the carries because some of the additions that we're going to have are going to be larger than 10. So there will be a little bit of carrying, but it'll be fine. It'll be just like we did with whole numbers. The 2 plus 7 is 9, so I'm going to put my 9 in the answer section, just below the 2 and the 7. And there's no carrying there because 9 is only one digit large. The 4 plus 6 is 10, and so I'm going to put a 0 below the 6 in the answer section, and I'm going to carry a 1 by writing it above the 9. Next, 9 plus 4, as I look at that column, is equal to 13, and when I add in that extra 1 from the carry, it's going to give me 14. So I'm going to put a 4 underneath the 4, there in the answer section is where that 4 goes, and I'm going to carry a 1 above the 2 in the next column. So I'm still working my way right to left. And now I have 2 plus 8, which is 10, and I add in that extra 1 from the carry, and that's 11. And we can just write that in front of the rest of our answer because there are no more columns of numbers to look at. And so I've just put an 11, if you will, or a 1, 1 into the answer section. And now I'm done because I walked my way all the way through the problem from right to left, and my final answer is 114.09. Now, before I move to the next example, let's ask ourselves if this answer makes decent sense. It's always important to do a little bit of critical thinking when we can about whether we've done the problems at least in the right ballpark, at least having answers that are close, if not exactly right. But here, let's look at the original problem. It was 29.42 plus 84.67. Now, that's about the same as 30 plus 85 approximately, right? 29.42 is about 30, 84.67 is about 85. If I add 30 and 85, I get 115, and that's really not that complicated to find. If you want to do it, you can. It's 115. Now, did we get an answer earlier which was close to 115? Sure, 114.09 is a little less than 115, but it's certainly in the right ballpark. It's about the same size. So we have confidence that we've done this problem correctly. Now, let's move on and do another decimal number addition problem. This time I've added a little bit of twist to make sure that we're on the right track with these decimal numbers. Here's what we're going to do. Find 113.24 plus 45.607. Now, with this example, I want to start testing our skills a bit with these decimal numbers, just a bit more. So what's the first thing we need to do? Well, we're going to write the problem vertically, as we've done with our previous examples, and we have to line up the corresponding digits and use our decimal points as the main way to do so. So I write my numbers vertically, and I'm going to write those decimal points one above the other, and if I do it right, then I'm going to have, for example, the 2 above the 6 and the 4 above the 0, and it looks like the 3 is going to be above the 5, and so on. Now, let me pause here and make two quick comments. First of all, yes, I see that there's a 7 sort of dangling off on the end all by itself. It looks a bit odd, maybe a bit suspicious that there's nothing above it, okay? But that's exactly where it ought to be. That 7 doesn't have to have anything above it, and really, to be honest, we need to just leave it there. That's the right place for it, okay? Now, secondly, I actually chose this problem carefully by giving both numbers exactly 5 digits. And the reason I did that was it would be extremely tempting for us to have written the numbers with the 5 digits so that each one had a digit above the other. In other words, I could have written them so that the 4 was above the 7, and the 2 was above the 0, and the 3 was above the 6, and so on. Now, that would be very understandable to do, but unfortunately, it would be very wrong to do. And the reason it would be wrong to do is because if you then look at where the decimal points are, the decimal points are no longer right above each other, vertically, one above the other. They've gotten shifted away from each other if you try to rewrite the problem the way I just suggested. That's bad. Those decimal points must always be one above the other. And that is a huge hint that we've not written the problem correctly if we push all the digits so that each one has a digit above or below the other. So remember, even though some of the digits might not have what I might call a partner digit above or below, We need to ignore that. We've always got to line up those decimal points, and if that means that one digit is hanging off on one end or the other by itself, not a problem. And oh, by the way, that grid paper might really come in handy when we start having these numbers where the digits are sort of scattered a bit, like that 7 that's in this problem hanging off on the end. So you might want to get some of that grid paper so that you can keep everything lined up the way you want. Now, let's get back to this problem. We have 113.24 plus 45.607. We've lined everything up so that the decimal points line up, and we draw our nice little horizontal line, and we need to write in that decimal point in the answer section. That decimal point is going to help us keep everything in its correct place. So put that in there now before we ever start adding any of the numbers up. Now, once that's done, we start on the right-hand side of the problem and we work our way to the left. So we see that 7 all alone. What do? What are we going to do because that 7 doesn't have a corresponding digit above it? Well, just think of it as having a 0 above it if you want. And if you were to add that 0 to a 7, you just get 7. So I'm going to write a 7 in my answer section. Next, I'm going to move over one column to the left. I see a 4 plus 0, which is 4, and so I write a 4 in my answer section just under the 0. Next, 2 plus 6 is 8, so I'm going to write in that 8 in the answer section. Then I'm going to have 3 plus 5, which is 8, and I'm going to write in that 8 as well. 1 plus 4 is 5, which we write in to the left of the 8. And lastly, we have that 1 that's sort of dangling on the left-hand side. Again, it's just like adding that 1 to a 0, which really isn't there, and that's going to give us a 1. And so I'm going to write a 1 in the answer section on the far left side of our answer. What's my final answer then? Well, thanks to having that decimal point already put in before we ever did any of the addition, I know that the answer is 158.847. Now, as before, we can at least check this answer by estimation, just to see if the whole number estimates would be about the same. Well, the original numbers are close to the whole numbers 113 and 45. If you add those two whole numbers, like we've done in some of our previous lessons, you'll see that 113 plus 45 is 158. And 158 is very close to our final answer. Now, that's not a perfect guarantee that our final answer is exactly correct, but it does mean that we didn't make some huge mistake which we should have caught by now. Now, I'd like to move to another example where we calculate with decimal numbers and we do some addition. Here's the example. Let's calculate 643 plus 82.987. Now, I see some of you saying, wait a minute. I can't do that problem. There's no decimal point in the first number. What in the world are we supposed to do? Well, if that's you, just take a breath and relax. We'll be fine. Remember that we know something about those digits of those two numbers. For one, we know that the 3 in the number 643 is in the ones digit. So we know that if we wanted to put in a decimal point in the number 643, that decimal point would go just to the right of that 3. And that tells us exactly how to write these two numbers vertically so that the correct digits line up. If you want, I could write it as 643 with a little decimal point after it, plus 82.987 just underneath, written vertically. And yes, the two numbers look very much misaligned given the way that the 987 is just sort of hanging out there all alone. But that really is the way they have to be written, because the most important thing is to line up the digits using the decimal point. Now, once we've written these two numbers in this vertical fashion, I can write my little horizontal line, and the first thing I'm going to do is put that decimal point right into the answer area just below the two decimal points in the problem. It's very important that we do that. Now, I start doing this problem the way I've done all the others. I just add from right to left in each column. Well, the 7 and the 8 and the 9, which are to the right of the decimal point, they don't have anything to add to them. I mean, you could imagine that there are some zeros above them if you'd like, but basically there's nothing to do there other than just to put that part in the answer. In other words, I'm going to have a 7, an 8, and a 9 put right in to the answer section. Again, think of them as being added to 0 if you'd like. So up to that point, I would have 0.987 in my answer. And now I just keep going from right to left. 3 plus 2 is 5, so I write a 5 just to the left of my decimal point. 4 plus 8 is 12, so we write in a 2 and carry a 1. And lastly, the 6 has nothing below it to add to it, but it does have the 1 that we just carried. So the last thing we're going to do is 6 plus 1, which is 7, and I'm going to write a 7 in my answer section as well. And now I've done everything from right to left, and so I know my final answer is there in front of me, 725.987. Now, I'd like to transition a bit into some subtraction problems before we close this lesson today. Now, the same rule applies with subtraction that we had with addition. We have to line up those decimal points. Otherwise, the problems follow the same basic principles that we used when we were subtracting whole numbers. So the key here is line up those digits using that decimal point as a good marker, and otherwise, you're just going to subtract the exact same way we subtracted whole numbers. So let's do a first example. Let's find 84.23 minus 51.72. Let me suggest, in fact, that we take a moment and let you try that on your own to see how you do, and then we'll come back together to see what the final answer is. Okay, so let's write the problem vertically, just like we did with whole numbers when we were subtracting, and let's line up those decimal points. And when you do, you're going to have 84.23 minus 51.72 with the decimal points aligned. Draw that little horizontal answer line, if you will. Put in that decimal point right now, just below the other two decimal points. And now you just start subtracting right to left again. So we're going to start with the 3 minus the 2. That's 1. That's easy enough done, so we put the 1 in the answer section. Next, we can't subtract 2 minus 7 from that tenths digit because the 2 is too small for the 7. So I'm going to have to borrow, just like I did with whole numbers. In fact, what we're about to do is like changing $1 into 10 dimes, if you want to think of it that way. We're going to the tenths column now, which is sort of like a dime related to a dollar bill. Taking 1 away from that 4 and replacing that 4 with a 3, we now have 12 minus 7 in the tenths digit. And 12 minus 7 is 5. So I'm going to place a 5 under that 7 just to the right of the decimal point. Now, in the ones digit of my problem, I now have 3 minus 1. Remember, it's not 4 minus 1 because we had to borrow 1 from that 4. So it's now 3 minus 1. And so in the answer section, I'm going to put a 2 because 3 minus 1 is 2. And I put that 2 just below the 1. And lastly, I have 8 minus 5, which is 3. That's easily done. And so I'm going to write a 3 in the tens digit of my answer. And I've worked through all the columns. And so my final answer is in front of me. It's 32.51. Now, let's try another subtraction example so you can see the kinds of things that can happen in those kinds of problems. They're not really complicated, but I'd like to make sure you see the different things that can happen. Let's do the following. Let's find 42.75 minus 8.1. Well, as with all the other examples that we've done in this lesson, we need to start by writing the problem vertically and lining up those decimal points. Once you've done that and you draw in your horizontal line right in that decimal point in the answer section, it's extremely important that you do that. Some students really do forget to put decimal points in their final answer, and their answers are often wrong then because that decimal point is missing. So put that point in, and now let's start subtracting. First, as we're doing things right to left, we see that 5. But the 5 doesn't have anything underneath it. So what do? Well, as we've already seen, we can pretend that there's really a 0 underneath it. And if you do that, you're basically going to have 5 minus 0, which is 5. Okay, so I'm going to write a 5 in the answer section, basically vertically below the 5 that was above in the problem. I move over one column to the left. I see 7 minus 1 is 6. And so I write a 6 in the answer section below that 1. Now we want to find 2 minus 8. But I can't do that because the 2 is too small. So I'm going to borrow from the 4, which is in the tens digit, and that leaves a 3 there Don't forget that. And now I have 12 minus 8 in the ones digit. That's 4. So I'm going to write a 4 in the answer section below the 8. And all that's left is that 3 that's in the tens digit. But now it doesn't have anything below it either. What do we do? Well, again, I'm going to pretend that there's a 0 below it. And 3 minus 0 is 3. So I write a 3 in the tens digit of my answer. And the final answer is 34.65. Now, let's look at one more example which shows some of the complication that can occur when we subtract decimal numbers. So here's that example. Let's calculate 25.7 minus 10.483. Well, it looks gentle enough. It looks like the same kind of problems we've been doing. So let's just go after the problem in the usual way. Write the numbers vertically, one above the other, if you will, lining up those decimal points. Write out that horizontal line right in that decimal point. I know I've said it, I don't know how many times in this lesson, but it's very important that we do that. So our decimal point is there. And now I'm going to start on the right, and I'm going to do the subtraction and work my way from right to left. Well, I see that 3, but it doesn't have anything from which to be subtracted. There's nothing above it. And that's a problem. So at this point, we should probably write in some zeros in that 25.7 to get some subtraction partners, if you will, for both the 8 and the 3 that are sitting in 10.483. Well, that means my problem now looks like 25.700 minus 10.483. Now that looks better, and I like that. So now let's start on the rightmost column and do the subtraction. Well, except we still have a problem, because 0 minus 3 is not something I can do. The 0 is smaller than the 3. But never fear, we can borrow, so we'll do that. Except the column just to the left also has a 0 in it. I can't borrow from 0. If I have no dollars, you can't really borrow dollars from me if I don't have any at all. So what do? Well, here's what we do. We can actually borrow twice. It just means we need to march over 2 columns to the left and start the borrowing there. And once we do that in a step-by-step way, we can actually finish the problem. So let me show you how. We start by borrowing from the 7. And I'm going to take 1 away from that and turn it into a 6. So rewrite that as a 6 just so we don't forget that it's now had 1 borrowed from the 7. Now that makes a 0, the 0 above the 8, into a 10 because we're going to put that 10 into that position. But we still need to take care of the 0 that's above the 3. So before we do anything else, we're now going to borrow 1 from that 10 that we just put above the 8. That's going to give me a 9 above the 8 because I'm borrowing 1 from it. And now I'm allowed to put a 10 above the 3. And now, believe it or not, we've taken care of all of the borrowing. Did you notice how we had to do 2 of them? But now that we've done them one step at a time, we're actually set to do our subtractions. Okay? So now let's do them. Starting on the rightmost column, 10 minus 3 is 7. So I'm going to write a 7 below the 3 in the answer section. Now the next column is 9 minus 8, which is 1. So I write a 1 below the 8. Then I move over. 6 minus 4 equals 2. And so I write a 2 below that 4. Then 5 minus 0 is 5. And so I write a 5 below that 0. And 2 minus 1 is 1. And so I'm going to write on that leftmost digit, if you will, a 1. And now, folks, I've worked through all of the digits of the problem, and our final answer is sitting in front of us. It's 15.217. Now, it's very important that we say something here about neatness. I'm sorry to really focus on this throughout the course, but neatness is extremely important as you're writing the steps of this problem. As long as you're keeping track of all those borrowings in a neat and careful manner, everything is going to be fine. But if you're really sloppy about it, it's going to be really hard to keep track of whether something's a 10 or a 9 or a 7 or a 6 or whatever. So be really, really careful as you work through those details. Next time, we're going to move on to multiplication and division of decimal numbers. I'll see you then.